All right, so tonight we're going to look at most of the right-angled trig and the trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. The first topic we're going to look at, though, is special right triangles. It's kind of like a one-off topic, but special right triangles are actually probably the most important right triangles. If you're kind of doing any kind of building or construction, all your triangles or angles are going to be based on the 45, 90 triangle and the 30, 60, 90 triangle. So these two are the basic ones that most people should know. It's also, if we look back at our unit circle, the same values on the unit circle as well. Those are we do 0, 30, 45, 60, and 90. So these same angles appear in these special right triangles. You should see the two rules down the bottom. Those are going to be the rules always for this. So when we're looking at these problems, we're going to set up the triangle and then we're going to set up the rule. So if we're looking at the first one here, I've got h over 7. And now I'm going to match them to the rule that works with the 30, 60, 90 triangle. So the h is on the bottom, the 60 and the 90 part of that one. So that's going to be a 1. And the 7's on the side there, so it's the 90 and the 30. So that would be the square root of 3. So we have triangle and then my rule. Once we have that set up, we cross multiply. So I have square root of 3h equals 7, and then we divide by the square root of 3. Now, this topic wants you to write it in simplified radical form, which means you have to do the rationalization of the denominator. So I have 7 over the square root of 3. So to rationalize it, I basically move the square root up top and leave the number down the bottom. So it becomes 7 square root of 3 over 3. On this topic, you're always going to have one of each rule, the 30, 60, 90, and then the 45, 45, 90 triangle. So the next one's 45, 45, 90. So I have that b over 6. And now again, I'm going to match it up. So the b is on the square root of 2 side, and the 6 is on the 1 side. So cross multiply. So I get b equals 6 square root of 2. So those are my two answers. So we're just going to put those in the box here. And we check. So basically, this problem just comes back to looking at the rule and looking at similar triangles to match up your sides. Any questions on the special right triangles? All right. Next thing we're going to look at is just some simple, we're going to look at going into the basically right triangle trigonometry. The first two topics are pretty simple. This one's really easy. All you're doing is typing the calculator. So you're just going to do tangent of 38, sin of 46, and cosine of 80. You can use any calculator you want. The Alex calculator actually works pretty well for this. So I would actually probably just use the Alex calculator unless you have a scientific or a graphing calculator or a scientific calculator that shows you out what you're typing in. If you have trying to do it on your cell phone is not going to work very well unless you actually are shown what you're typing in. The other thing that is on this topic to make sure you're doing is make sure you round correctly. So this is 0.0 or 0.62. And then sin of 46. Now, when you're doing these, your sine and your cosine should never be bigger than 1. So if you get something bigger than 1, when you're doing your sine and your cosine, you probably made a mistake. So 0.17. How did I get my tangent wrong? I must have typed something wrong for my tangent. 7, 8. Yeah, the first one was tangent. I must have. Oh, I hit sine. That was why. Okay. I was like, I must have typed something wrong when I typed into the calculator. Tangent can be any of them, so that tangent actually can go from +1 to or all the way all the numbers. So the closer you get to 90, the bigger the number is going to be. So you do want to actually keep that in mind. Sine and cosine only between -1 and 1. Oh, so here's the thing. Depending on the calculator you're using, your calculator is probably in radians mode. So look on your calculator and see if it says DEG or RAD. So if your calculator is in radians mode, you will not get it. You'll actually get a different answer. So all these problems for this set of topics are in degrees. So make sure your calculator is set to degrees. On the graphing calculators, go to mode, and then it should be one of the options there. So good thing to check to make sure your calculator gives you the right answer for it. So when you're doing the topic, I would look at the first, like the example one, and just make sure you can get it on your calculator to make sure your calculator is set correctly. Because yeah, otherwise you're going to get them wrong and you're not going to know why. This is a topic that looks extremely hard because it's really, really big, yet it's really, really easy. You're actually going to do exactly what it says. So it says JK. So we're going to divide JK. So 18.55 divided by KL, which is 7.92. And then we just round. So 2.34. All three of the first ones should come out to be the same. If they don't, you made a mistake. So I typically do at least 2 of them just to make sure that I didn't mess up on the first one. 74.2 divided by 31.68. And I'm going to get the 2.34. And then you can divide the last one and it should come out to be the exact same again. But we know it's going to come out to be 2.34. Row B, same thing. You're just doing exactly what it says. You're not using anything from row A and row B. So it's sin of 66.9. Cosine of 66.9. And then tangent of 66.9. You will notice that when you round to 2 decimal places, the answers come out to be the same. However, if you looked past those 2 decimal places, they're not exactly the same. So it's because they rounded in the triangles. So, but rounding to 2 places, you definitely get the exact same answer. So in this case, tangent matches the top, so the answer is tangent. Sometimes the problems that have lots of words and everything else in it actually are pretty easy. It's just they look difficult. All right. So we looked at our unit circle and we did our functions from there. Now we're going to look at the right angle trig. Right angle trig, you can do the same way. You can use your x, y, and r. Sometimes it's easier to do opposite, adjacent, hypotenuse, just because those are the functions that you used. So if you remember, if you ever did trig in high school, your teacher probably taught you this. SOHCAHTOA. That stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, when we're looking at these in terms of my x's and y's, this is y over r, this is x over r, and this is y over x. So those both are ways to look at your sine, cosines, and tangents. So now, whenever you're doing a right angle trig problem, the first thing you have to know is where are you standing, because your opposite and your adjacent switch depending on where you're standing. So if I'm standing for this problem, we're standing at B. So that's where I'm standing. So now the opposite is across from that. So that side's my opposite. The hypotenuse is across from the 90 degrees. And then my adjacent is where I'm standing next to. If we were standing at A, my opposite, my adjacent switch. So the number one mistake that people make in this topic is they assume we're always standing in the same spot. They label your opposite and adjacent the same way every time, and they're wrong. So if you're doing that, do make sure to write them down and label them out, and you won't make that mistake. Sometimes it's pretty easy to get those confused in your head if you're just doing them there. The other mistake on this topic is they don't always do sine, cosine, and tangent in order. They mix them up. So don't just automatically assume it's going to be sine, cosine, tangent. Make sure you read the problem and put the answer in. So this one is cosine first. So we've got adjacent, so 7 over 25. Tangents next. So I've got 24 over 7. And then sines last, so I got 24 over 25. All three fractions should also be different unless the numbers in the problem are the same, which I rarely see that in this topic. So just make sure, again, you're labeling your sides, and then you're picking your points. All right. So this topic's another one, like the two topics ago, that said it just has a bunch of steps in it, but it's pretty simple and straightforward to do. So the first thing we're going to look at is we're going to look at the letters. So we're standing at, if we're standing at T, so if we're standing at T, that's your opposite, that's your adjacent, and that's your hypotenuse. And this one's having us stand at both of them, so you kind of got to label them twice. So if we're standing at U, that's your opposite, that's your adjacent, and that's your hypotenuse. So sin or sine is opposite over hypotenuse. So for T, that is T over V. And cosine is U over V. Now, cosine of U is T over V. And sine of U is U over V. So what they're looking at here and what they're trying to show you in this topic is that sine and cosine are equal to the opposites of them. So if you take the other side, they're going to come out to be the exact same value. T and U are complementary because they both add up to 90 degrees. Sine T is equal to cosine U. Cosine T is equal to cosine U, no. Sine T is equal to sine U, no. Cosine T is equal to sine U, yes. Since they're complementary angles, that means cosine of 36 has to equal the complementary angle to that for sine. So this would be 54 because it's whatever is going to equal 90 degrees. Any questions on that topic? Or does that make sense? So your sine and your cosine, they're equal when you do your complementary angles, is in essence what this topic is looking at. So sine of x, so if we're standing up here, sine, so this is my opposite, that's my adjacent, and that's my hypotenuse. So sine of x is x over z. Cosine of x is y over z. Now if we do we're standing at the y, that's my opposite, that's my adjacent, and that's my hypotenuse. So cosine of y is x over z, and sine of y is y over z. So in this one, they actually put them next to each other. You notice angles are the same. Those the two values are the same. So because x and y are complementary to each other, they add up to 90 degrees. It's going to switch to complementary in a second. Since they're complementary to each other, they add up to 90 degrees. I don't know why it's not refreshing on that. So there we go. So they're equal to each other. If you think about it in terms of the unit circle, if you looked around the outside, the 30 for sine of 30 is the same as cosine of 60. And this is why sine of 45 and cosine of 45 are exactly the same. Those values are the same because they're complementary of each other. So it's just those little things that we can see even on the unit circle as we're going around that they do make them to be the same. So then we just got to mark which ones are the same. Sine of x and cosine of y, and cosine of x and sine of y. And then if it's 64, the one that's complementary to that would be 26. So it's just all going around that complementary angles. All right, so next one we're going to look at is the next few topics we're going to look at is we have to find the exact values for trig functions. The problem in this one is they're only going to give you a couple of sides. You need to find the third side. So to find the third side of a triangle, if we have two, we have to use the Pythagorean theorem. So in this case, I've got a squared plus b squared equals c squared. So I've got 7 squared plus x squared equals 25 squared. So oh, that's up to 25. Subtract 49. And we got x is 24. So this side right here is 24. So now tangent is my opposite over my adjacent. So that's my opposite and that's my adjacent. So in this problem, as was typed in chat, is 24 over 7. If it came out to be a square root, you would have just put the square root there. So this one we could actually do the square root of it. So we were able to do it, but they're not all going to be able to be done. So same thing. The only difference is this one, we've got multiple values that we're going to have to find. Same concept. We have to find the missing side first. So I've got 5 squared plus x squared equals 8 squared. So we've got x equals the square root of 39. So if I'm standing here, that's my opposite, that's my adjacent, that's my hypotenuse. Cotangent is the reciprocal of tangent. So tangent is opposite over adjacent. So cotangent is adjacent over opposite. So it's 5 divided by the square root of 39. I believe you can actually put in, you don't have to rationalize them, but we're going to find out in a second. Cosine is adjacent over hypotenuse, so it's 5 over 8. Secant is the reciprocal of cosine, so it's 8 over 5. And you don't have to rationalize it, so just leave it as is. Any questions with 6 or 7? Before we go on to the next ones? All right. All right, so this topic right here really uses the unit circle. So if we're looking at our graph, remember, sine is y over r, cosine is x over r, and tangent is y over x. So if r is always going to be positive and 1, that doesn't really matter. So in this quadrant up here, my x is positive and my y is positive, which means my sine, my cosine, and my tangent are all positive. In this quadrant, my x is negative and my y is positive. So in this one, my sine is positive, but my cosine and my tangent are both negative. In this quadrant, my x and y are both negative. So my sine and my cosine are both negative, but my tangent is positive because 2 negatives make a positive, and we would have x over y, or y over x, which would be positive. In this quadrant, my x is positive and my y is negative. So my sine is positive. Oh, sorry, backwards. Cosine is positive. My sine is negative. My cosine is positive, and my tangent is negative. So when we're looking at this problem, we want to figure out which quadrant they're going to be in. So the first one says tangent is less than 0. That means tangent's negative. And sine is less than 0, so sine is negative. So which quadrant has sine's negative and tangent's negative? And that would be in quadrant 4. Next one says cosine is negative and sine is positive. So cosine's negative, sine is positive. That's in quadrant 2. Let's do one more of those. Depending on the unit circle that you went and looked at, some of the unit circles actually have these, like all the actual trig functions and the signs built around it. So tangent's negative and cosine is positive. So tangent's negative and cosine is positive. That's quadrant 4. Cosine's positive and sine's positive, and that's going to be in quadrant 1. So they're never going to be multiple quadrants. There'll always only be one quadrant that it'll actually both work in. Any questions with that one? All right. I think that's the end of those, and then we're going to work on solving some equations now. Nope. 1 or 2 more of these. All right. So this one, they give us the point of the terminal side. So in this case, they gave me -2 and -3. So that's my x and that's my y. So the piece that I'm missing is my r. So we have to do my Pythagorean theorem. So I get -2 squared plus -3 squared equals r squared. So the square root of 13 is r. So it's just one of those things you're going to have to remember, unfortunately. You can use the unit circle and draw the triangle. If you can remember opposite over hypotenuse and those on your unit circle when you're drawing it out, and I'm actually going to do it on this one anyway. So if you draw your triangle out, so let me do that in a different color. So if we draw our triangle, if we're standing here, that side's my opposite, which is my y value because it's going up and down. This side's my adjacent, which is my x value because it's going left and right. And then that side's my hypotenuse, which is my radius. So you can come up with it, work on it. If you remember the SOHCAHTOA, you can use it to create the x, y, and r from the unit circle. So now we've got our x, our y, and our r. Now we're just going to plug them in. So sine is y over r, so it's -3 divided by the square root of 13. Cosecant is the reciprocal of sine, so that's going to be a negative square root of 13 divided by 3. And cotangent is the reciprocal of tangent, so that is x over y. So that's going to be -2 over -3, which is just 2/3. So once you find your x, y, they're going to give you the points. So they'll give you the x and y. Once you find your r, it's just plug into the points. Let's do one more of those. So this one, we got -3 and 5. So I've got, so it's the square root of 34 is r. So cosine is x over r, so it's -3 over square root of 34. Secant is reciprocal of cosine, so negative square root of 34 over 3. And then cotangent is x over y, so -3 over 5. So the hardest part of this one is just finding your r, and then it's just plug and play from the equation or the rules. All right, so now we're going to start solving some equations for your trig functions. There's lots of little ways to remember these. The one thing that I always try to tell people, especially if you're not really good at these, is always set up your equation first. So in this case, that's my opposite and that's my adjacent. So opposite and adjacent is tangent. So I have tan of 46 equals x over 5. A quick little shortcut way to remember it, or for how to do it in the calculator, if the variable's on top, we multiply. If it's on the bottom, we divide. So in this case, since my x is on top, I'm going to multiply. So when I multiply this, I'm going to put the number in first. So you always put the number in first. So it's 5 times tangent of 46. So in this case, my answer is, and we're rounding to the nearest tenth. Do make sure to look at what they're rounding to because they always change them up. So this is rounding to 5.2. Now, once you get your answer, you can look at the triangle to see if you did it correctly. So it kicked me out for a second. So the bigger the angle, the bigger the side that's opposite of it. So in this case, my opposite is across from a 46. That's going to be the bigger of the two angles because the angle up top would be 44. So it's going to be a little bit bigger than the other side. So in this case, 5.2 is bigger than 5. So I probably did it correctly. So just little things you can use to check your work before you hit check on the actual problem. I would do another one of these, except we're going to do like 3 more of these in the next couple topics. So. The next topic is actually dealing with work. Apparently, my Wi-Fi is giving me issues today. If all of a sudden I stop talking, just tell me. Just type picnic. That works. Next time I'll hardwire my laptop in. All right, so this one, we're standing at the 72. So this side's my adjacent and that side's my hypotenuse. So we're going to be using cosine for this one. So it's cosine of 72 equals 12 over x. Since my variable's on the bottom, I'm going to divide. So I'm going to put the 12 in, and then I divide by cosine of 72. So in this case, my answer is, and we're rounding to the nearest tenth, so 38.8. And again, that makes sense. My hypotenuse should be the biggest side of the triangle, and it's much bigger than the 28 or the 18 that's going to be on the other angle. So 38.8 totally makes sense for this problem. They will always give you the picture, so you'll never have to draw the picture.
Professor, could you say what the equation was again?
So it's cosine of 72 equals 12 over x.
Okay.
Can you not see my screen?
No, I can see it. I just
okay.
I thought there was.
Okay, no, because I'm apparently there's a little issue,
that.
so I just want that's fine. I just wanted to make sure that you actually could see it. So yeah, so the only one I did in the calculator, so I put the 12 divided by cosine of 72 in the calculator. So that's how you actually solve out that answer. So you get the 38.
Yeah, the part I missed. Yeah.
Yeah, so if the variables on this case, the variables on the bottom, so we're dividing. If the variable is on top, like the last problem, we multiply.
Okay, thank you.
No problem. All right, got one more problem like this. Now this problem is again the same exact thing. We just have to do it twice. So the first question is always going to ask you for the other angle. It's just the complementary of the angle they gave me. So they're giving me 42, so the complementary to that is going to be 48. So we're just taking 90 away from 42. And that's big A. Now we're going to set up our triangle, so we're going to label our sides. So that's my opposite, that's my adjacent, that's my hypotenuse. And we're going to find them one at a time. So we're going to look for A first, which is my adjacent, and we have my hypotenuse. So I'm going to use cosine. The 42 equals A over 24. Since the variable's on the top, we're going to multiply for this one. So I do 24 times cosine 42. And we get 17.8. The next one we're looking for is B. That's opposite. So I have opposite and hypotenuse. So I'm going to use sine. So sine of 42 equals B over 24. Again, since my variable is on top, I'm going to multiply. So I'm going to do 24 times sine 40 or 24. I think I did 42 on the last one. I did do 42 on the last one. Oh, no, it was 42. Okay, that one was right. The angle. 42s and 24s, too close together. So this one's 16.1. Now, that makes sense. My opposite should be smaller than my adjacent because my 42 is smaller than the 48, the complementary angle on the other side. So that makes sense. So notice these three topics that we just did are basically the exact same thing. It's just how they're displayed and written is a little bit different, but it's the same concept for all of them. All right. This one, again, it's the same thing, except it's looking at multiple triangles, and the problems look a little bit more complicated. So the hardest part of this problem is just figuring out what they're asking you for. So this one, the surveyor wants to know the length of a tunnel built through the mountain. So I'm basically looking for that value and that value. Those are the two values I'm looking for. And I'm going to add them together to get my answer. So let's find each of those values. So we're going to label our triangle. It's no different than we were doing in the other ones. So we're standing here. So this is my opposite, and that's my hypotenuse. The same thing on this one. That's my opposite, and that's my hypotenuse. So we're going to use sine for both of them. So the first one is sine of 57 equals x over 212. And the second one is sine of 14 equals x over 119. Oh, sorry, x, y. So my x is going to be 212 times sine of 57. And my y will be 119 times sine of 14. So notice how when I'm doing this, I didn't do anything in the calculator yet. You don't want to until you're going to type the entire problem into the calculator at once. Because if you try to do it in pieces, you're going to write down answers and you're going to round. So, and you don't want to round because as soon as you start rounding, you're going to get further off. So, and unfortunately on these problems, when you're doing them with the calculations, a little change can make a big difference at the end. So we're going to do 212 sine 57 plus 119 sine of 14. So they want to round to the nearest tenth at the end, so it's 206.6 meters long. We'll do one more of these. Just because all the pictures are a little bit different. And I want to see if I can get one with the subtraction built into it. Oh, more of those. There we go. So looking up, Christy sees two hot air balloons in the sky. She determines that the lower balloon is 700 meters away at an angle of 38 degrees. The higher hot air balloon is 1,050 meters away at an angle of 26 degrees from vertical. How much higher is the balloon on the right than the balloon on the left? So in this case, I'm going to take the taller balloon, so we'll call that x, and we're going to subtract off the y to figure out the difference in the heights. So we're going to do x minus y in this problem. So we look at it. So that side in the middle there, if we're standing there, that's going to be my adjacent side for both of them. And those are going to be my hypotenuse. So both of these are going to use cosine. So the x is cosine of 26 equals x over 1050. And then the y is cosine of 38 equals x over 700. Oh, that's a y. So now all we're going to do is just subtract those two. So it's going to be 10,050 times cosine of 26 minus 700 times cosine of 38. So we just type the whole problem in. So 1050 6 minus so we get 392 meters. 0.1. So those are really the only two ways. They're either going to be addition or subtraction. And looking at the picture, you should be able to tell pretty quickly which one that's going to be. And the addition one, it doesn't matter which one you put first. The subtraction one, you do have to make sure you put the right one first. Although if you get a negative answer, you know you did it backwards. So just switch them. All right, last three topics. So we've been looking for sides. The other thing I can do is I can find the angles. So in these problems, we're going to look at the inverse functions. So if you notice when we're looking at sine and cosecant, cosine and secant, and tangent and cotangent, they are reciprocals of each other. They're not the inverses of each other because they flip them over. On your calculator, you have a button that has sine -1, cosine -1, tangent -1. Those are not the reciprocals of them. They are the inverses of them. Another way you'll see them written in books is the arc sine, arc cosine, and arc tangent. So you'll see them written either way. A lot of times people see the -1 and think that's the cosecant for sine, and it's not, and you'll get the wrong answer. So in this problem, we're going to put those numbers in. So it's just going to be tangent -1 of -0.83. So we got -39 point, and they want us to round. Oh, here's a great little reading thing, and I just caught it. It wants the answers in radians. I just found the answers in degrees. So we have to make sure we change our calculator to radians. So -0.69. So do make sure you can switch back and forth on your calculator, and do make sure you read the question that it's asked, which terms it's asking for them in. So cosine of -1 is 1.26. And that's going to be undefined. Because remember, cosine has to be between -1 and 1. So if we're putting in, so we're finding the angle. So there is no angle that's out there that's going to give me an answer when I find the cosine of it of 1.26. So we know that's undefined. Your calculator will give you a couple different answers. Your calculator could give, most calculators will just give you as an error. So if you get the error, it's going to be undefined. The Alex calculator does give you the term undefined. And then we do sine inverse of 0.78. And that gives me 0.89. So just make sure to read in the problem what it's asking you to determine, if it's either radians or degrees. All right, last two. So these two, we're going to use those functions, and we're going to find the angles in a triangle. So we're going to do the same thing. So that's my opposite. That's my hypotenuse. So it's sin of x equals 16 over 18. Since the x is in my trig function, I'm going to use the inverse. So the sine -1. So I do sine -1 of 16 over 18. So my angle in this case is 62.7. And the last topic is the exact same thing. It's just with a word problem. So you'll see a couple, it's looking for angle of elevation or depression. Same thing, you're just looking for the angle. So this one is adjacent and hypotenuse. So I'm doing cosine of x equals 5 over 12. So it's cosine -1 of 5/12. So you get 63.4.
It was 65.
Oh, 65.
Yep.
Okay, that would make why. I'm like, wait a second. There it goes. Now I can't click in the box. There you go. Now I got them all right. All right. That's all the rest of the topics. I have a lot more time, so if there's questions you guys have on any of the other topics, you can ask them. I'm going to stop the recording for this way I can post this up for this set of topics. But if you have questions on any of the topics in section 6.1 or 6.2, now would be the time to ask them.